All right. Hello, everyone, and welcome to our talk about Townforge with the title An Overview of the Aspects of Townforge Related to Privacy, Security, and Censorship Resistance. A little bit of a disclaimer or intro. The contents of the talk here have been provided by Moneromooo, who I'll be referring to out of convenience as Mooo, the main/sole developer of Townforge. And I am Syksy. I'll be narrating these slides, and I have only contributed minor adjustments to the presentation and such. So this is really Mooo talking here. So from this point onwards, whenever I'm referring to I or me, I'm really talking on behalf of Mooo. So in Moo's own words about this talk, I was invited to submit a MoneroKon talk about Townforge's merge mining scheme. This talk will be about a bit more than this, the various aspects of Townforge related to privacy, security, and censorship resistance, the stated interests of MoneroKon. So what is Townforge? Townforge is essentially a Monero fork with heavy modifications. At its base, Townforge is a Monero-style cryptocurrency and can be simply used as such. However, there is a whole online game embedded into it, the playing of which is totally optional, although we do heavily encourage it. This game is entirely contained into the blockchain and the Townforge consensus rules. No central server is needed, and the game actions consist of blockchain transactions carrying all the necessary data. This implies that the entire game state is contained in the chain, and that the entire game history can be fully viewed and replayed by just looking at the blockchain and interpreting its transactions using the Townforge consensus rules. This makes Townforge an online game that is fully decentralized and permissionless. Townforge game accounts are created by a particular type of transaction. Again, this is fully permissionless. No central server registers the account. All other Townforge node operators will interpret that transaction as the creation of that account and will from then on allow that account to perform in-game actions. There is thus no way to censor someone from playing the game. Moreover, the game keys associated to an account are derived from the wallet's main address, secret spend key, and thus a game account cannot be linked to a Townforge wallet address without knowledge of the wallet's secret key. However, game actions are linkable. If Dog uses his wallet to create a game account called Eric the Red, no one will know Eric the Red is Dog, even if Dog has linked his name to his wallet address on many merchant sites, exchanges, or published it online. On the Townforge internet, nobody knows you're a dog. All in-game actions by that account will, however, be seen to be performed by the Eric the Red game account, but with no link back to Dog's wallet address. Townforge Gold, as is the name of this currency, can be transferred at will between the base Monero-style output-based layer and the game layer, which is based on accounts and balances. Again, this is fully permissionless, without any centralized privileged party managing player balances. A deposit or withdrawal is based on a typical Monero-style transaction paying yourself, but may have another input and/or another output. The input decreases an in-game balance while the output increases the balance. Consensus rules still check that the sum of inputs and outputs is equal. The difference with Monero is that the amounts of gold going in and out of the game are clear text. As in Monero, out-of-game amounts are still hidden, protected by ring CT. In-game balances can thus be viewed as a new kind of output with a variable amount. In turn, most in-game actions will use this balance to pay for things, including the transaction fee. This system allows typical game actions to be very small since they do not have to rely on a full Monero-style transaction. While a typical 2-in, 2-out Monero transaction weighs more than 2 kilobytes, an in-game transaction typically weighs about 100 bytes. There are some exceptions, such as building a large 3D model or creating a custom item with a large text description, etc., since all this extra data is included in the transaction. This dual output/balance based system allows the game to function with the regular money supply instead of creating or destroying in-game credits based on player creation and actions. Whatever players do, the money supply remains only changed by block subsidy, which is composed of 3 elements: POW block rewards from mining, optionally merged mining, POS block rewards from staking, accounting for 5% of POW block rewards, and a subsidy of 10% of block rewards going to the automated consensus-controlled town treasuries. Both merge mining and POW/POS hybrid mining will be the subject of a later section of this talk. The game is basically a city building game, focusing on the economical aspects. Originally, I tried to find a way to make it work with Monero proper, but 2 main issues prevented it. In order for the game to be on-chain, it would need the game actions to be embedded in Monero transactions and validated by consensus, which was obviously not going to be possible, and even if it did, the extra on-chain bloat and increasing transaction distinguishability would hurt Monero. Other differences from Monero include the removal of payment IDs, lock times, and an aggressive 20-second block time. While this may increase the orphan rate, it makes for a more satisfying game, as constantly waiting for a block for your actions to alter the game state does not make for a great experience. As for the emission, it's basically very similar to Monero, scaled by 1.83. Townforge will emit 183 gold in the same time Monero emits 100 Monero, and with higher tail emission, which hits after about 8 years, similar to Monero. The higher tail emission ensures continued incentive to play the game in the long term. A last difference is the inherent circular economy provided by the game, where there is constant demand for gold to create new buildings and other in-game actions. And then comparing generally to MMOs out there. One issue with MMO games is the dependency on central servers. Once these go, the game is usually not playable anymore, at least online. Some games provide the ability for people to run their own servers, or gamers find a way to do so anyway, but this is by no means a certainty. Running a decentralized game on top of a blockchain solves this problem by making every player, and indeed anyone running a Townforge node, whether they play the game or not, equal participants in keeping the game alive. As long as people want to run a Townforge node, the game stays alive. The game state is uniquely determined by the blockchain itself. This means that there is no central database that can be tampered with, say, change a player's balance, owned items, and so forth. A player's balance is the sum of all income and outlays from previous transactions, including the special game tick transactions, which are auto-generated by consensus rules themselves and serve as a game heartbeat. This setup means that once a player deposits gold into the game, the gold can only be used by A, that player using their own secret key, and B, consensus rules which are fixed and determine how land tax is paid, how buildings condition decay, how badges are awarded, and everything in between. The heart of the economic game in Townforge is powered by those tick transactions, which happen 4 times a day. These are created strictly by consensus rules. Every Townforge node will create the exact same tick transactions from the same chain. Again, there is no leeway for anyone to try to cheat by ticking the game in one's favor. Modify your node to let the tick favor you, and the other nodes will reject your tick. This also goes for the game creator. This protects the game against an exit scam. Note that the game creator does have extra powers, but those are fixed in the consensus rules and generally are geared towards improving the game's ongoing story. While it is not 100% perfect, it goes a long way towards preventing issues with the game creator being able to abuse the game at will to the detriment of others. Another important part of the economic game is the marketplace. Players can buy and sell built-in items as well as player-created items. This marketplace is fully decentralized. A buy or sell order is, as everything else, a transaction. Unmet orders are not mined until they are paired with a matching order, at which point both are mined, if they were not mined already, and the resulting trade happens. Matching can be done either by the taker or by miners if they find 2 unpaired matching orders that can be paired. Here again, there is no central server managing the marketplace, so no censorship is possible. But what about vandalism and such? Without the ability to censor, won't the game be overwhelmed by spammers and vandals and so forth? Townforge uses a middle ground here. The game creator has the ability to maintain a list of undesirable accounts, player-created items, cities, and buildings. By default, the game will use this list to hide those. Note that the term hide is important here. The players in the list can still play the game unhindered, but most others will see, for example, player number 476 instead of seeing Bob hates ethnic group X, whatever that X is. This both makes the game more approachable and decreases the incentive for players to troll and otherwise abuse the game and its players, while still allowing everyone to play. None of the economic levers of the game are touched by this hiding system. Bob's buildings will have the same income, abilities, etc., whether or not Bob ends up on that default list. The term default is also important here. While the game will hide whatever is on the list by default, players can opt out to ignore this list, displaying everything in its unfiltered state, or even make up their own list based on their own preferences. Other mitigations against abuse include a small account creation fee, fees for a creation of custom items with bonuses. This mitigation also applies to the game creator account, which can create such items and thus would be able to gain an advantage over other players if there were no such fees. And more generally, fees for various other actions where repeated use of it would create scaling or balance issues. An important consideration for any blockchain is security provided by the miners. Townforge will merge mine with Monero in order to benefit from free security from miners already mining Monero. Merge mining is transparent for pool miners who perform the same work as if they were mining Monero alone. The only change is how the data that is being mined is constructed. Townforge's merge mining scheme is basically copied from Namecoin, which introduced it quite a long time ago, so it is not a new technology by any means. Townforge's implementation is designed to allow many chains to be merge mined at once with Monero. In particular, Tari which is not a Monero fork, will also merge mine with Monero and is expected to use the same scheme. We would then have miners securing 3 blockchains at once for the same energy expenditure as they would be mining Monero only. Merge mining is optional. One can still mine Townforge in the usual way similar to Monero. Doing so will, however, miss out on the potential block rewards from finding a Monero block while doing so. And as said, the merge mining is optional. Townforge is currently still in testnet, but there is a demonstration pool supporting merge mining, only one chain though. Other pool implementations would need modifications in order to support merge mining, so it is not expected that most Monero hash rate will also secure Townforge. Hopefully some will, and hopefully that share will increase over time. Technically, merge mining works by creating a block template for Townforge and placing its hash in the Monero block. Generically, the root of a Merkle tree containing the hashes of all the merge mine chains is placed in the Monero block. In the case of a single merge mine chain, that root is the hash itself. Mining on this Monero block, a miner now has 2 difficulties to meet: the Monero difficulty and the Townforge difficulty. The Townforge difficulty is expected to be substantially lower than Monero difficulty. So if a miner finds a block that meets Townforge difficulty but not the Monero one, that block becomes a valid Townforge block but not a valid Monero block. The block can then be added to the Townforge blockchain, even though the block is a Monero block. The Townforge consensus rules consider this block to be a valid Townforge block. Technically, the block added to the Townforge blockchain is a Townforge block which contains the coin-based transaction from the Monero block. The actual Monero transactions, for example, are not included. Townforge provides a merge mining proxy which will act like a Monero node's RPC server and will automatically return a merge mining block when asked for a block. This allows existing code that expects to mine Monero to be left unchanged or barely changed and still be able to merge mine Townforge. The proxy itself will be connected to both a Monero and a Townforge node, allowing it to query both to create a merge mining block template from the Townforge and Monero block templates. It will then claim the lower of the 2 chain difficulties and decide which chains to submit a new block based on the difficulty achieved by the miner. It is hoped that other merge mining chains will use a similar system so that proxies can be chained, leading to easy to use merge mining of multiple chains at once. Note that a drawback of this merge mining scheme is that the host creating the block template must have access to a node for each of the chains. For pool mining, that would be the pool server. Pool miners themselves will not have to change anything, but will be able to supply an additional Townforge address if they want to receive Townforge gold rewards in addition to their Monero rewards. There remains a chink in the security armor here though. Due to the huge expected hash rate imbalance between Monero and Townforge, the first major Monero pool to decide to merge mine Townforge will suddenly make up what is likely to be more than 50% of the Townforge hash rate. This will continue until another large pool decides to also do so. Townforge addresses this by employing a hybrid POS system. Having 2 subchains with independent difficulties means that an attacker with more than 50% of the network hash rate, the POS subchain, will be unable to sustain an attack on Townforge without also having a substantial part of the staking power, the POS subchain. For example, a miner using NiceHash to attack with 60% of the Townforge hash rate but no staking power will be able to dominate the POS part of the chain but not the POS part of it. Since the difficulties for PoE and POS are independent, a PoE attacker switching to Townforge will run the PoE difficulty up, but its POS difficulty will stay constant. After the PoE difficulty settles down to its new high, the attacker will still find fewer than half of the blocks despite having 60% of the Townforge hash rate. If the attacker mines a secret chain only to unleash it later, that is, none of the PoE nor POS blocks found by honest miners are included in that secret chain, then during the average time it takes for the attacker to generate 10 blocks, the public chain will have generated about 6 PoE blocks and 6 POS blocks. Consensus rules are set up to favor an even distribution of PoE and POS blocks to further increase the cost to an attacker. The cumulative difficulty of a chain is no longer the accumulation of all the difficulties of the blocks in the chain, but the product of the accumulation of all the difficulties of the blocks in each subchain. To avoid special cases at chain start, Townforge adds 1 to each of those subchain cumulative difficulties. Here we want to see what happens if we add 2 or more blocks. They'll be either 2 PoE blocks, 2 POS blocks, or 1 of each. It follows that on average, an PoE attacker would have to get between 67% and 75% of network hash rate to be able to overcome the PoE-POS hybrid system. That is, the attacker would have to come up with 2 to 3 times the hash rate of the network before the attack. The attack would then be able to mine 3 PoE blocks in the time it takes for the remainder of the network to mine a PoE and a POS block. Would the attacker mine 2 PoE blocks, they'd lose versus the other miners 2 PoE/POS blocks. This improves on 51%, but of course it isn't magic. A possible way to enhance this would be to enforce some PoE and POS blocks interleaving to some extent, but this would have drawbacks, such as blocking the entire chain if only one of the subchains suddenly loses hash or staking power. PoE and POS chain difficulties are independent of each other and, as in Monero, depend on the timestamps and a single block difficulties of each of the blocks in a recent window. A well-known issue with difficulty adjustment algorithms is their inability to quickly react to a loss in hash power, or in the case of POS case, staking power. Townforge takes advantage of having 2 different subchains to modify that difficulty adjustment algorithm slightly to mitigate this. Each subchain has a block time of 40 seconds, and when calculating how much cumulative difficulty was mined during the difficulty adjustment window, blocks from the other chain are taken into account, deemed to add 0 work. This has the effect of using that other chain's block timestamps in a chain's difficulty calculation, so that if a subchain starts getting starved of blocks, its single chain difficulty will start dropping as new blocks from the other chain cause the difficulty adjustment algorithm's inputs to be the same amount of work, or decreasing amount of work, for a longer time frame. This will cause the starving subchain to accept lower difficulty blocks and help it recover more easily. The last point about POS is that staking power is not defined before. While PoE relies on random X hashes per second, POS typically relies on amount of currency. For Townforge, this would be counterproductive, as we want people to use their gold to play the game, not keep it unused so that it can be staked instead. The solution is to stake not gold directly, but in-game buildings, which are the most salient in-game object at the center of the economic game. In turn, to avoid people just creating buildings and doing nothing else, the same kind of bonuses that apply in-game also apply to staking power. For example, player prestige increases the staking power for all that player's buildings. As a last mitigation, POS block rewards are set to 5% of the PoE block rewards. Since POS does not require expending energy, there is no reason why POS and POW block rewards should be the same, and a smaller POS block reward still ensures that players will have an incentive to stake, while preventing an overwhelming incentive to optimize for staking at the expense of playing. 5% being better than 0, this should not meaningfully decrease the overall staking power available. I whimsically call Townforge's POS proof of settlement, since staking power is based on actually settling the land. Townforge also features private messaging on the blockchain. These messages are embedded in Monero-style transactions in a way that makes it impossible for an observer to even know whether a transaction contains a message, let alone its contents, its originator, or its recipient. CLSAGs, the type of ring signatures used in Monero and Townforge, contains several 32-byte values used as entropy. These are scalars normally randomly generated by a cryptographically secure random number generator. However, Townforge can replace some of them by ciphertext from a message. Each 32-byte value can hold up to 252 bits, as scalars don't use all the full 253-bit range of the 32 bytes. One bit is used as a flag, and the others hold the payload. The data is then encrypted with the recipient's public key and sliced up to fit the available S values. The larger the message, the more of these 32-byte values are used in this way. The remaining ones hold random scalars as usual. There is a slight drawback to this, however. The 32-byte values used in this way are the S values in the CLSAGs, one per ring member. The recipient of a secret message, and only the recipient, can tell which of these are used to carry a message payload, and can deduce that the matching ring member is not the true spend. This means that the larger the message, the lower the effective ring size is as far as the recipient is concerned. Other observers are unable to make this deduction though, since they do not know which S values contain payload. Indeed, they are unable to tell whether a secret message is carried by a transaction at all. To combat potential spam, those secret messages are gated by a fee system. The first message from Alice to Bob requires a fee from Alice to Bob. If Bob replies to Alice, Bob will pay Alice the same fee. Players can also block messages from any other player. The messages will still go on the chain if sent, but the game will ignore them. This takes care of large-scale spam operations. Any further message is free of this first-time cost. In parallel to private on-chain messages, Townforge also supports real-time public chat also on-chain. This is implemented, like pretty much everything else, as transactions which are never actually mined. They are held in the text pool and will slowly time out. This makes this chat a transient communications system without any blockchain impact. The contents of this chat are fully public. Still, Townforge has a few centralized points. The main one that cannot be avoided is a game account, to which Moneromooo and Syksy hold the secret keys. This account is a normal game account but holds some extra powers which are designed to offer a good middle ground between all powerful centralized game admins and no powers at all. For example, custom items created by the game account may have prestige and building bonuses, but these come with a fee dependent on these bonuses. This prevents the game account from creating huge bonuses which would skew the economic game in their favor. Other powers include the creation of storyline scripts to give flavor and continued interest in playing the game, the ability to bypass some anti-abuse restrictions, such as a limit on the number of in-game places that can be named, and so forth. The game account also receives 0.25% of the gold in town treasuries on game ticks. This compares to about 9% going to players and 0.1% to town mayors. The game account gold is meant to be used to pay for hosting and other expenses, as well as provide prizes for manual in-game events such as competitions, for example for architecture and such, and to allow the game account to create buildings and perform related in-game actions to support storytelling. Since the game creators have the technical ability to withdraw the full amount of this gold, it can be considered a dev tax. Lastly, a couple more mostly centralized but optional aspects are the avatar sharing and the IPFS proxy. Players may create custom items and optionally assign them an arbitrary image to form an NFT on the Townforge blockchain. Note that they are totally incompatible with any Ethereum-based NFT systems. These images are maintained on IPFS. However, given the availability issues on IPFS, the Townforge seed node server also runs an IPFS node which pins those images along with a proxy, letting the game have quick access to those images. While this is centralized, it is also optional. Players can specify their own IPFS gateway for direct IPFS access. The avatar sharing system is an ad hoc system also run on the Townforge seed node server, where players can advertise their in-game avatar's position and in turn get notified of other players' avatars' positions. Such sharing is optional, but creates a more engaging playtime when you can see other players moving around in the world. Both the IPFS proxy and avatar server are included in Townforge Git repo and may be run by any person, so if the Townforge seed node becomes inaccessible or I become evil, anyone can run them and people just have to tweak their game configuration to point to the new server's IP. Wrapping up, the main points of contact, really, if you want to contact, you would be joining our IRC channel, Townforge at Libera chat, where you can have a discussion with Mooo, for example. And the official website for Townforge is townforge.net, where we, for example, have the Git. We do offer multiple other platforms as well, mainly maintained by me, now talking as Syksy. This includes Discord, Twitter, Reddit, and Telegram to a degree. However, mainly, for example, Discord serves as a bridge to the IRC, so I would really encourage focusing on the IRC. And some acknowledgements and credits as provided by Mooo. Sorry about that. So obviously, huge thanks to the Monero project, and then Kayaba Nerve for the idea of using BPS values as payload, JT Grassi, the pool code I used for adding merge mining support, Tari for the idea of using geometric mean for whole chain cumulative difficulty, Sarang Norther, sanity checking of the secret message scheme, Sec1 bug reports for multi-chain merge mining, and P2Pool support for merge mining, Rockneum, Throlus, iDunk, Celsta, Dunamelon, and many more for playtesting and bug reports. So that's about it. I am Syksy, speaking on behalf of Mooo and the Townforge project. I hope you enjoyed this presentation. I hope you have a great MoneroKon and hope to catch you in game. I will try to put up a video showcasing our gameplay if the time allows it, but that remains to be seen. But have a great time and thank you for listening. Cheers.